All right, hey, it's me, John Park, and welcome to John Park's Workshop. I am excited to have you here today, and we're going to kick things off on this 808 day by throwing this thing up here. It is CircuitPython Day. How about that? Huh? Whoa, where'd I go? It is CircuitPython Day. And there are some exciting things going on CircuitPython Day. First of all, I believe there are community events going on all over the place, so check your local hacker spaces, maker spaces for things like that. Also, we've got a live stream at 7 o'clock Eastern Time tonight with Katney, who is going to be playing her keynote speech she did, or talk. Is it a keynote? I can't remember if it's a keynote. I think it's a keynote. Great talk. I just watched it the other day. I really encourage people to check it out. It was from Pi, Ohio, and she's going to be playing that, and I believe also manning the chat. And I'm checking my notes here because we also have at 8 o'clock, yeah, it was a keynote. There's my note. At 8 o'clock, Scott and Lady Ada and Mr. Lady Ada are going to be doing a History of CircuitPython live stream. So please go check that out. And I'm actually going to also mention that if you head to the store, I believe for any orders over $49, we're going to be giving away a CircuitPython ruler. And the CircuitPython ruler is super excellent. I just got one the other day, although I got a red one, and now there's a purple one. So what am I to do? How many colors are we going to do? Do you want to collect them all? So the CircuitPython ruler is both a helpful engineering ruler, particularly for circuit board layout, because it has the pad sizes and values and things for a lot of parts, both, I believe, through-hole and definitely surface mount parts. And it's a functional Trinket M0, so it's you can plug it right into USB and off you go. It's also got some capacitive touchpads on it, so you can use it as a keyboard or other input device, which is wild. And I believe there's a setup when you plug it in that'll allow you to use the Unicode characters just by hitting the omega sign and the pi sign, and I forget what the other one is. So $49 in the store, and I believe you'll get that for free on your checkout. So pretty cool. Now, let's see. What else have we got? We have this. This is our Help Wanted sign. And if you'll bear with me real quick, I'm going to try to fix one of my... oh, you can see the black hole if you want. Yeah, let's fix that. It's more interesting that way. Let me change the source on this thing so that it's my Firefox session. How about that? This is how you know this is live and not pre-recorded, because look at these mistakes. All right, that's the one. All right. Yeah, there we are. So jobs board I mentioned. Check out this. This is a new one I just saw on the jobs Adafruit.jobs or jobs.adafruit.com. And this is a Makerspace Technology Creative Instructor position at Tech Ahoy, which is a nonprofit community space in Queens/Brooklyn border. That sounds really interesting. So go check that out. You can do so by heading over to jobs.adafruit.com, where it is free to post jobs, and it is free to post your resume and info if you're looking for work. All right. So what else do we have? We have a coupon code. Remember I mentioned going to the store? Well, 10% off in the store if you use today's coupon code, which is CODFISH. CODFISH will get you 10% off in the store on anything you want to buy other than software gift certificates and subscriptions. And speaking of things that you might want to get in the store with your 10% off, my product of the week pick is this 3.5-inch TFT Featherwing. This thing is really cool. In fact, I'm going to jump over to my overhead and let's go to the big one. There we go. I still have the wrapper, the screen protector on here. But this is a ginormous TFT that is a feather wing. So you can plug a feather right into it. I've got this running on a Feather, I think that's an M0, no, M4, I can see it on the screen there. Feather M4 running Circuit Python, and this is using, actually I checked out a tutorial that Melissa had put up about using it, and I don't have much of an interesting demo on here right now, but huge, cool display. So if you're looking to use a Feather M4 or M0, or probably most of our Feathers, along with a big screen for some readouts of some kind, or whatever you can imagine, that's a great choice. So that's my pick of the week right there. It's the 3.5-inch TFT Featherwing. And let's see, what else? Oh, I wanted to mention, I had in the news mentioned that, of course, it is our CircuitPython day, because today is 8/8. But it's also 808 day. You can see I've got my shirt on to match for the 808 TR-808 from Roland drum machine that revolutionized hip-hop and lots of pop and electronic music. And today's 808 day as well, so go play some beats. That's why I programmed those beats that we heard at the top of the show. And now it's time to get into a little thing I like to call the Make Code Minute. All right, so give me a second to set up here, because I'm testing something new today where I can actually hear the output of the Make Code session. Let me keep this from banging around. So let's grab the Chrome browser here. Okay, so what I wanted to talk about today in the Make Code Minute is how to use the brand new melody block to create tunes inside of Make Code Arcade. Up until now, there's been some one block at a time methods where you could play notes, but now there's this little sequencer in here. So I grabbed this in music, and now you can see there's melody, play melody, cute little icon there, and it is an 8-step sequencer. So I've set the BPM here to 240, and I've laid in some notes, and you can actually preview your notes. So, okay, so you get this little octave, and now I've gone in and programmed something so I can hit play, and it's great because you can test it as you go. And then to play a little more interesting thing, I've actually got some polyphony going, so I've got 2 notes going on at a time with these forever loops. So I'll go ahead and hit play and check it out. And that is how you can create tunes in Make Code Arcade using the melody block. Where'd I go? Hey! All right, so now what I wanted to jump into is the Make Code Arcade Game of the Week. So I'm going to bring up my Chrome browser again, and I'm excited about this one. This one is called Trogdor Endless Burnination. And I didn't remember this at first, but this is actually a meme from Homestar Runner. Strong Bad was a character in the web cartoon Homestar Runner, and he taught you how to draw a dragon called Trogdor. And this is a game called Trogdor Endless Burnination by Dragon Mountain Design, who is probably some sort of dragon kin of Phil B. That's my guess. So if you check this out, let's see. Can I go? Yeah, let's look at the game. So I'm going to go to the simulator here. Trogdor Endless Burnination. And it starts, and now you can use your arrow keys to move Trogdor around, and your goal is to eat villagers and burn down huts by shooting fireballs. Oh, I just so that's the basic gameplay of Trogdor Endless Burnination. And now I wanted to take a look at something I thought was nice, the way he used this sort of randomizer in the code to determine which object is going to be flowing from left to right. So you can see there are these knights that you can burn but don't eat. There are these huts that you can burn. There's spears you want to avoid. And there are the little helpless peasants that you want to eat or burn. And so what he's doing in this block is on game update every half a second, there is a variable called choice, which is set to a random value between 1 and 4. And then these if, choice, else, else, else statements here decide, based on whichever of those random numbers is picked, which particle or projectile is going to be sent across the screen with the character sprite or the weapon or the house. And so I thought that was a really nice, simple and clear way to set up a sort of random choice without making it complicated or using the percent blocks. Instead, it's just going to pick a random number, and you're going to get a dice roll as to which character comes across the screen. So that is my game pick of the week, Trogdor Endless Burnination. Okay, let's see. I'm going to check in on the chat because it's always nice to see how people are doing over there. Hey, C. Grover is in. He's saying my voice levels are peaking at -8 dB. Maybe we can crank that up a little bit. Let's see. Yeah, that looks really low. I wonder why. Oh, let me turn that. Yeah, I'm turning knobs. All right, hopefully that works out for us. And so let's see. Oh, game sounds were much louder than my voice. Thanks for letting me know. Sorry about that, Mr. Certainly. I hope that was at all audible. Could you hear it? Do you want me to redo it? Because I'll redo it if that's not audible, since I'm going to be breaking off a MakeCode minute. Let me know. Otherwise, I'll just re-record it later. Mr. Certainly is typing. Oh, I should show you guys the chat while I'm talking to the chat. That's rude of me. There you go. We're all waiting on the 3 dots. The 3 dots of Mr. Certainly typing. And C. Grover. All right. What's the verdict going to be? Do we re-record that? We may never know. You guys are typing a lot. Of course, with the lag, you probably never heard me ask that question, and there are just puns coming. Oh, we can hear you okay. Okay. Cool, thank you. All right, so moving on then, I had a couple of, actually I had one other quick thing I wanted to show. Let's switch over here for a second to my workbench before we get to the project of the week. So let me move that out of the way. And then we'll go right into the project of the week. How about that? So I've been doing my best to learn Eagle CAD for developing circuit boards. And one of the things I was testing with was a really simple board, but just to try to get the steps down and get the PCBs made at Osh Park, I made a little breakout board for our 45 millimeter potentiometer sliders, slide pots, faders. So this is not breadboard friendly unless you bend the wires out. You can do it, but it's a bit tricky sometimes. So I just wanted to break out all those pins, and I got this upside down. It was a bottom of the board footprint I used on the top of the board. But luckily, I can just place these on the bottom of the board, and it works out just fine. So here you can see. That's what it'll look like. I can gang up a bunch of these on here. So you saw a couple weeks back I did a NeoPixel color picker using the bigger sliders and some cardboard, I think, or some wood. I used some wood. I didn't mount them on a board. I just soldered directly to them. But this allows all these to break out onto pins, which is pretty helpful. So having fun with that, and I just wanted to show that because I think it's a useful thing to think about if you're going to use those slide potentiometers. Is maybe you want to make a breakout board of some kind, or you can hand do it. You can send them off to get them made. So next thing is, let's go into our project of the week, and I'll slide into it starting with these. So these are some cranks for our rotary encoders, and let me grab a rotary encoder real quick so I can show you the bare element and what I'm using it for. So this is, let me switch cameras again for you. focus. So this is one of our rotary encoders that we sell, and it's an endless encoder, meaning it, unlike a potentiometer, it doesn't stop. Oh, it's really liking that blue. It's trying to zoom in on that blue. Always trying to guess what the Sony autofocus algorithm is up to. So this allows us to measure values going up or going down or left to right, as well as it's a push encoder, so it has a little clicker on there. And when the Playdate game machine was announced a few months back, people started adding cranks to small handheld gaming devices, and we did it too. The Ruiz brothers came up with a really nice case design and some crank designs for attaching these to a Pi badge and a Pi gamer. And so my project is using that, but the fact that we now have rotary encoder support, it's inside of MakeCode Arcade, meant I wanted to give that a try in MakeCode Arcade. So what I wanted to do is make a fishing game, which Lamore suggested, which is a really natural one for a rotary encoder. And so that you're not sitting there twisting this with your fingers, I wanted to use one of the cranks. This is one of the designs that Pedro made. It's a print in place, and you can see here it fits on the end and it turns the potentiometer for you. Excellent design. And there's these two pieces that actually are separate models that have a little gap between them in the 3D model, which means when they print on the printer bed like that, they're actually separate from each other, and so you get this captive piece, which is awesome. Since I was going to be doing some fishing instead of just a general use, I wanted to extend the crank out a bit longer, and I gave it a little curve just for style mostly, and a little shape on the end there. And so this is the design I came up with to use for the fishing crank, and you could go and add one on the other side. A lot of fishing reels have that feature, so that you can break it with your hand, I suppose. So that is the crank I'm using on the rotary encoder, and I've got the case here that the Ruiz brothers made, and you can see how it fits in there really nicely. There's a cutout. There's also a case top that I'm not using on here just because I liked the way it looked seeing the guts and the face of this board. I really like showing off the silk screen on this board. It's a beautiful one. So you can see this rotary encoder is wired, and there are wires running underneath and into the feather headers that are on the back side of the board. And if you check out the Ruiz brothers Learn Guide on this, it shows you exactly how to set it up. I'm using analog pins 2 and 3, so there's 2 analog pins which are red, or there's 2 pins which are red on the board. And then there's a ground connection, and there's also a switch connection for this push button. So let's have a look. I think this might be a good camera, actually. It's a little better than my down shooter for this lighting. So I can show you how the game works. So what happens is I want to be able to first, if you see that hook there. In fact, you know what? Let me show you it on screen. It's a little hard to simulate because of the rotary encoder. So let's jump over to this MakeCode session and jump into my final tab. So since the rotary encoder is in use and the digital pins are in use, it's difficult to use the simulator. So what I've done is I've set up a debugger that takes those out of the program. I don't think I have D-pad working anymore. I did at one point, and now I've broken it. Oh, do I? Maybe I do. Let's restart that. No, it's doing a weird thing when I hit up. Oh, I know why. It's trying to cast it. Okay. But here you can see the basic game. So I did a couple little sprites for fish, and then I have this line and a hook. That guy's probably going to get caught. Yep. And you'll see fish go by sort of slowly, left and right. Let's hit A, and it'll want us to recast, and I don't. Let's see, I might be able to recast. No. So you'll see fish coming on both sides, and I painted a little background there. I've also created a foreground layer, and all this is, you can see that top fish is actually kind of out of the water a little bit, And when I show you on the reel game, you'll see when I reel a fish up, it'll come out of the water. So the way I'm doing this is MakeCode Arcade doesn't offer alpha channels or transparency or partial opacity. So what I've done is I've set up a checkerboard pattern, also called dithering, of the light blue and the transparent blocks. So it's either fully transparent or it's fully blue, fully light blue. And then the background behind it is a similar pattern, but offset by 1 pixel in each axis. So that gives us a little bit of movement on the fish, which was accidental, but kind of cool. Looks a little like they're swimming or some distortion under the water. But the nice thing is it allows me to have them behind a layer. And so I'm using Z depth to do this. So if we look at the code here, I can show you, I don't know how well you'll see these. So this is the background, and so you can see the water I painted in there does have 2 tones of blue, and then this is the partially visible, let me try to zoom in there, checkerboard pattern. Can I, oh I can't get, it's too zoomed to see. Sorry about that. Okay, so this, you can see the sort of background through this, so you can tell that that's checkerboarded. And the way I did this is actually maybe a little bit painful, but I actually went into the JavaScript editor and copied a line of a smaller image, and then I hand used the 0 and the 9, which are the transparency color, and the light blue. And then I just kind of copied and pasted lines until I had something that worked. It was just, for whatever reason, a little more convenient in this case versus going out to another piece of software and using the asset tool to import it. So don't forget, you can go over to JavaScript and edit images as well. So let's take a look at actual gameplay on the overhead over here for a second. And so the essential gameplay that I wanted to use is I have this crank for reeling in the fish, and then we've also got an accelerometer built onto the PyGamer. So a lot of fishing games and a reel fishing rod, you will lock the reel with a trigger of some kind or a button, and then you'll pull back, you'll cast, and release the trigger when it's time to lock it. Do I have that right? I think I have that right. Hold it, cast it out, and then lock it. Yeah, so you'll let go as you're casting it out, and then you'll lock it. So that determines how far it'll go, and then it'll drop. So what I'm using to set this is the down arrow. So it's the down on the thumbstick or the D-pad if you're on a Pi badge. So when I do that, you'll see the hook disappears. Let me see if I can get in even closer. No, that's as close as I can get. All right. So the hook disappeared because it's waiting for me to pull back and then cast. And I let go, and you can see it's dropped down there now. And it picks a bit of a random X. So now I'm going to raise my fish up with this crank, and you can see there's a little message. It says good, too slow. So this is allowing me to have a little bit of gameplay where you have to roll the reel in, or crank the reel in at the right rate, like you're fighting a fish in the water. You can't pull too hard, or you can't go too weak, or it'll swim off. So what I'm doing is I'm testing, and I got some great help from Joey at the Microsoft MakeCode team. He helped me out late last night. It's like, how about this? And he came up with a really great succinct method of testing the rate that I'm cranking at, and then if I'm outside of the bounds going too fast, it'll warn me you're going too fast. Too low, it'll warn you too low. And then I have a little counter that's checking how many times we end up with one of those messages. If we're out of bounds 20 separate times, then you lose the fish. It says that one got away, and now I have to hit A to clear that message, and it starts me over again. So we'll cast again. Hello? There it is. It's a little hard to cast and try to stay in camera. So now I'm waiting on a fish. And there are certainly a lot of things you can do in a fishing game that I haven't done here, like maybe shake to set the hook would be cool. All right, here we go. So as long as I go at a consistent rate now, it's saying good. Oh, too fast. Good, too slow. Good, good. Oh, that one got away, so I was close. All right, let's try it again. All right. That one got away again? Okay, I swear I'm gonna catch one of these. It's my own game. All right. That one got away again. Okay. I need to tune this. So great thing about it being a make code game is you'll be able to go in and set how hard it is. I've made it a little too hard now. I was getting this good before, but it's when I had my reading glasses on and I could see the too slow or too fast message a little bit better. Oh, I'm sorry. I'm getting out of screen. All right, we'll try it one last time. Let me grab some glasses because I'm determined for you to experience the awesomeness of catching a fish in this game. All right. Here we go. Is everyone ready? I'm ready. All right, here we go. Try to catch. All right, it's going to be this guy. Here we go. It said that one got away. Maybe I've got an error in the code now. Darn. Okay. So when it does, let me show you what happens. We can take a look at the code over here. Game is just too darn hard. So let me switch here and there. Okay. So you'll see I've got a bunch of comments here. Actually, I'll close this for a moment so you can see a little more space. Let me zoom out. So I'm using comments in this to make it easier for me to know what I'm doing with different blocks, and for anyone who looks at the code, you can right-click on any block and click Add Comment. I don't know why it put the comment. Whoa, I can't do that. I put the comment block far away. Where's that? There it is. So this is a comment associated with this debugger. So I can say when debug is off. And then you can minimize that and it just collapses it into this little bubble here. And these show up in JavaScript as sort of regular comments like you'd expect with I think a hash pound sign in front of them. Or is it slashes? I can't remember in JavaScript. Okay, so if I had if I had gotten a fish up, this is the message block that we would get. It'll say, you caught it. This one weighs, and then I'm picking a random value between 2 and 18 pounds. Could be a little medium-ish fish to a pretty darn nice big fish. And it says, nice. So let's see, what else is interesting to talk about in here? The basic flow of things, the way I'm setting things up is in extensions. You won't see them here because I've already added them, but I've added the controller extension. And controller extension adds the crank. And then I'm also adding the feather extension, and the feather extension adds the pin definitions that I need. So in the beginning of my onStart block, if my debugger is off, then it's going to set these 2 pin definitions that I need. One is the pull pin, and that's how I'm using the button. I'm using pin 9 as a pull down, or rather pull up resistor pin for checking a button press. And then the crank pin, this set crank pin, this comes out of, if we look in the controller block options, down at the bottom here, we have these 2 new ones. This is a fairly new extension, which are crank position, which is the value, the sort of raw value we're getting out of the rotary encoder, and then set the crank pin A and B and then you get to choose the pin. So if we look at the choices here, we get the LED pin, the serial data, serial clock, the UART. Is that UART? I think that is. RX, TX, and then all of the pins that you'd expect on the back of a feather, A0 through 5 and D1 through 13. And D2 and 3 are sort of special request ones we asked Microsoft team to put on for us, which are the 2 JST connector pins in the bottom of the Pi Badge and the Pi Gamer that you can also use. So that sets the 2 pins that are going to be read by the crank block, and if I zoom over to when I'm reeling in a fish, you can see I've got a bunch of math blocks around this, but essentially I'm taking the crank position directly off of the rotary encoder. That gives me a number, and for some things you may just use it directly. I actually wanted to reverse the direction of the crank, so you crank in the reel by going forward rather than backwards, which was the default. So I'm multiplying it by -1. I'm also removing the previous crank position because when we catch the fish it's way up here and then I want to pop it down below, so I need to offset it. Crank scaling, I'm actually making you go around 4 times for every, or rather I'm making you crank 4 times more than you would by default, so we move up the screen slower. So you could make it so it takes tons and tons of rolling to get that up. And then most of the other stuff is fairly straightforward as far as sprite usage, sprite collisions, the types of things we've done in a lot of MakeCode arcade games. This is the part that Joey helped me with, which is on a game update every 150 milliseconds if I have this variable caught. So if there's a fish who's actually been caught and is on the hook, and I know my word there isn't quite great because we actually haven't caught him yet, he's just taking the ride up the line. Then I start testing the current crank position against the past crank position every 150 milliseconds. So if that's greater than 5 and less than 10, then that's good. That's the rate I should be going at. If it's greater than or equal to 10, I'm going too fast. And you can see here this change fight counter. So the fight counter is the one that I set to, I think 20 is the limit. So when we get to 20 is when we fail to get the fish. Same with going less than 5 on the crank speed, so that'll say that we're going too slow. And this is the little output. So that is the basic flow of the fishing game on MakeCode Arcade, and I think it's really pretty cool that we can build that sophisticated of a controller input and gameplay on our Pi game or our Pi badge inside of MakeCode Arcade. And so with that, that just about wraps us up. I'll mention again our coupon code for the day is Codfish, and that will get you 10% off in the store. Also, don't forget, because it is CircuitPython Day, you can get yourself a free Pi ruler by spending $49 or more. You don't have to be exact about it, but no less, in the Adafruit store. Go pick up some cool stuff. And let's see, with that, I think that's going to do it. So I will thank you again so much, and please tune in to see Kattni's keynote talk live stream tonight. She's live streaming the pre-recorded event from Pi, Ohio at 7 o'clock Eastern Time, and then at 8 o'clock Eastern Time, tune in to see Scott and Lady Ada and PT talk about the history of CircuitPython. And I thank you so much for stopping by. This is John Park for Adafruit Industries, and I'll see you later.